As temperatures drop, be grateful you're not in the Boomerang Nebula, the coldest place in the universe. A place so frigid it defies the laws of physics as we know them. How can something be colder than the vast emptiness of space? Let's find out. The Boomerang Nebula stands as a testament to the universe's extremes, holding the record as the coldest known natural object. Its frigid temperatures make it even colder than the cosmic microwave background radiation. Situated in the southern constellation of Centaurus, near the Southern Cross, this enigmatic nebula is approximately 5,000 light-years from Earth. Despite its remarkable characteristics, the Boomerang Nebula remains invisible to the naked eye, revealing its secrets only through the lens of powerful telescopes. Let's get to know it. Now, each bright point we see is a star like our Sun. The Boomerang Nebula is located in one of the densest regions of the Milky Way, surrounded by countless stars and interstellar clouds. Traveling to this cosmic marvel is an unimaginable feat with our current technology. Our spacecraft today reach an average speed of 60,000 kilometers per hour. At this speed, a journey to the nebula would take approximately 90 million years. That's longer than the time it took for humans to evolve from our earliest ancestors. When it was first observed in 1980 through ground-based telescopes, the Boomerang Nebula appeared as a faint and simple boomerang-like shape, with few details visible due to the limited resolution of the equipment at the time. However, as astronomical technology advanced, the Hubble Space Telescope and submillimeter wave telescopes revealed a far more intricate structure. The nebula, now better understood, resembles an hourglass or butterfly with two symmetrical lobes spanning outward. This transformation in our understanding showcases the vital role of modern telescopes in uncovering the hidden beauty of the cosmos. It is classified as a protoplanetary nebula, a fleeting stage in stellar evolution that precedes the formation of a planetary nebula. During this phase, the dying star sheds its outer layers at an extraordinary rate, creating the expanding cloud of gas and dust we observe today. The term planetary nebula, however, is misleading. It originated in the 1700s when early astronomers observed these celestial objects through primitive telescopes, noting their round, planet-like appearance. Over time, improved observations revealed their true nature, remnants of dying stars ejecting their outer layers in dramatic bursts. The Boomerang Nebula is immense, with its gaseous envelope stretching across a distance of 4 light-years, roughly 37 trillion kilometers. To put that into perspective, this is nearly the distance between our Sun and Alpha Centauri, the closest star system to Earth. At the heart of the Boomerang Nebula lies a small white dwarf star. A white dwarf is the remnant of a star similar to our Sun. Although incredibly hot, it is much smaller and denser than a typical star. The white dwarf at the center has a diameter of only about 20,000 kilometers, comparable to the size of Earth, but its surface temperature reaches an astonishing 12,000 degrees Celsius, twice as hot as the surface of the Sun. In its earlier life, this star was much like our Sun. White dwarfs and planetary nebulae represent the final stages of stars with up to 10 times the Sun's mass. As their nuclear fuel runs out, they can no longer sustain fusion reactions, and gravity begins to compress the remaining matter toward the star's core. This gravitational compression generates intense heat, sparking a final burst of nuclear fusion in the outer layers of the star. The star then releases powerful pulses of energy, expelling its outer layers into space and exposing the hotter, denser core beneath. First, the outer layers expand dramatically during the red giant phase, fueled by the intense heat. Then, the core collapses into a dense white dwarf while the outer material is ejected into space, forming the stunning nebula we see today. After its core compresses, what remains is a dense white dwarf, a small yet incredibly heavy star remnant. Its density is extraordinary. A single teaspoon of its material would weigh several tons. Once a star enters the white dwarf phase, it no longer performs nuclear fusion. Instead, it begins to cool and lose heat very slowly. Over an unimaginably long period, the white dwarf may eventually transform into a crystallized sphere of carbon, known as a theoretical black dwarf. Black dwarfs remain a purely hypothetical concept, since the universe is not yet old enough for any to exist. Scientists estimate it would take approximately 1 quadrillion years, far longer than the current age of the universe, for a white dwarf to cool sufficiently to reach this phase. No black dwarf has been observed so far, and it is unlikely that one will be discovered in the foreseeable future. However, astronomers have detected signs of crystallization in the cores of existing white dwarfs, offering a glimpse into this eventual transformation. The region of the Boomerang Nebula records the lowest temperatures ever observed in nature. The gases in the nebula reach a staggering minus 272 degrees Celsius, just 1 degree above absolute zero. This makes the nebula colder than the background radiation of the universe, an almost unimaginable feat. High temperatures indicate that atoms are packed closely together and move at high speeds. At low temperatures, particles move much more slowly and with far less energy. Absolute zero is the lowest temperature possible in nature, where particles have the least amount of energy they can achieve. At this point, entropy, often described as the disorder of a system, reaches its minimum value. Entropy measures the molecular freedom of a system and the number of ways matter and energy can be arranged. In the Boomerang Nebula, the rapid expansion of gas leads to extremely efficient cooling, driving its temperature to record-breaking lows. The material ejected by the star travels at an astonishing speed of 590,000 kilometers per hour. To put that in perspective, at this speed, you could circle Earth in just 4 minutes. This velocity is 10 times faster than any spacecraft we've ever built and 100 times faster than similar stellar outflows. As the gas expands rapidly, it forms 2 nearly symmetrical cones in a process known as bipolar outflow. In the past 1,500 years, the central star of the Boomerang Nebula has shed a mass equivalent to 2 suns, or about 600,000 Earths. This extraordinary loss of material creates the expanding cloud of gas and dust we see today. The nebula's striking blue color results from starlight, reflecting off tiny millimeter-sized dust particles within the nebula. These particles are thought to contain silicates and carbon-based compounds, providing the building blocks for more complex cosmic chemistry. Despite its beauty, the Boomerang Nebula remains shrouded in mystery. Scientists are still unsure why its expansion is so rapid, as the energy output of its central star doesn't seem sufficient to account for this extreme velocity. The death of stars like this plays a critical role in the formation of stellar systems like our own. As they die, these stars synthesize and release essential elements, carbon, nitrogen, and dust particles into the universe, seeding the birth of new stars, planets, and under the right conditions, life itself. One day, the Boomerang Nebula will dissipate, its material drifting under the influence of gravity. Other solar systems could eventually incorporate this stellar debris, enriching their worlds with these precious remnants. If you enjoyed and learned something new here, don't forget to like and subscribe so you won't miss the next journeys into space. Is there a place in the universe you'd like to explore? Share your suggestions in the comments. Thanks for watching, and see you on the next star trip.